Let us solve some more examples of change of order of integration. To change the order of integration, and evaluate. Double integration 0 to root 1 minus x square zero to 1 e to the power y over e to the power y plus 1 into radical sign 1 minus x square minus y square dy dx. Now here the limit of this is for y. So y equal to 0 to y equal to root 1 minus x square, and this is y square equal to 1 minus x square, or you can say x square plus y square equal to 1, which is a unit circle, and x equal to 0 to x equal to 1. See, when both the limits begin with 0, then you should understand that the region of integration will be in the first quadrant only, and we have unit circle. So the region of integration is the first quadrant. So this is the circle x square plus y square equal to 1. Now the region of integration is as shown in the figure. It is the quarter circle. Okay, to change the order of integration, now we need to integrate first with respect to x. So to change the order of integration, let us take a horizontal strip. Say PQ in the region. And now we find the limit. So here the x is 0 to here it is on the circle. So x is radical sign 1 minus y square. And that strip move from here to here. That means y equal to 0 to y equal to 1. So therefore, integration 0 to root 1 minus x square 0 to 1 e power y over e power y plus 1 radical sign 1 minus x square minus y square dy dx, which is same as x equal to 0 to square root 1 minus y square, y equal to 0 to 1 Now we'll integrate first with respect to x. So this y is constant. E power y over e power y plus 1 is constant. This is dx over root 1 minus y square minus x square. Now this we can write as root 1 minus y square and square, like this, and minus x square. So that we can use the formula dx over root a square minus x square, and that is the integration is sine inverse x by. So this is y equal to 0 to 1 e power y over e power y plus 1. This integration is sine inverse x by square root 1 minus y square, and x equal to 0 to root 1 minus y square. So y integration y equal to 0 to 1 e power y over e power y plus 1. Now when you take x is equal to square root 1 minus y square, so then you will have sine inverse 1. Root 1 minus y square upon root 1 minus y square is 1. And when you take x to be equal to 0, so this is sine inverse 0. And sine inverse 1 is pi by 2. Sine inverse 0 is 0. So this is pi by 2. Y equal to 0 to 1 e power y over e power y plus 1. Now this is a f dash x over fx. So that integration is log of fx. So now this is a function and here it is a derivative. So that integration is log of e power y plus 1 y equal to 0 to 1. And so pi by 2, this is log y is 1. So this is e plus 1 minus log y is 0 and e power 0 is 1 plus 1 2. So minus log 2. So answer is pi by 2 log of e plus 1 by 2. Log a minus log b is log of a plus b. So this is the way you can have the change of order of integration where it is helpful to evaluate some integration. Let us take one more example. Change the order of integration and evaluate. Integration 0 to infinity, integration 0 to x, x e power minus x square by y dy dx. Now here this limit is of y equal to 0 to y equal to x equal to 0 to x infinity. So let us draw the region of integration. So here y is equal to x. This is the region of integration. Like if I take this vertical strip, then here y 0 and here y is x, and x 0 to x infinity. So This is the region of integration. Okay, so the region of integration is as shown in the figure. To change the order of integration, let us take a horizontal strip PQ inside the region, and then we find the limits. Here x is equal to y to x tends to infinity. This is endless, and this strip slides from here up to, that is indefinitely. That means y equal to 0 to y tends to infinity, and therefore double integration 0 to x 0 to infinite x e power minus x square by y dy dx equal to x is equal to y to infinity, y equal to 0 to infinity, x e power minus x square by y dx dy. Now we can take x square equal to, say, t, suppose. So then 2x dx is equal to dt, or we can say x dx is 1 by 2 dt. Then limits. When x is equal to y, t equal to y square. And when x tends to infinity, t also tends to infinity. So this is equal to integration 0 to infinity x dx x dx is 1 by 2 dt e power minus x square is t, t by y. So this is equal to 1 by 2. Okay, second integration limit is y square to infinity. Okay, t equal to y square to infinity. Y equal to 0 to infinity. This is e power minus t by y over minus 1 by y. T is y square to infinity dy. So this is equal to, you can take negative sign outside, y equal to 0 to infinity 1 upon y, so y Now this t tends to infinity, so this is e power minus infinity minus when t tends to y square. So this is e power minus y square by y, so e power minus y dy. Now e power minus infinity is 0. And this negative sign, we can write negative, negative, positive. So y equal to 0 to infinity. This is y. And this is 1 by 2 here. E power minus y dy. This is equal to 1 by 2. Let us take integration by parts. Y as it is. Integration of e power minus y is minus e power minus y. Then negative sign, derivative of y is 1. And integration of minus e power minus y is e power minus y, again minus sign, so minus minus plus. And y is 0 to infinity. So this is 1 by 2. When y tends to infinity, this is 0. And when y is 0, because of this y, that is 0. So e power minus infinity is 0. So in both the cases, this is 0. Now this is negative e power minus infinity, then minus e power 0. So that is 1 by 2. E power in minus infinity is 0. E power 0 is 1. Negative, negative, positive. And so answer is 1 by 2. We can take one more example. Change the order of integration and evaluate. Integration 0 to infinity, integration x to infinity, e power minus y over y dy dx. So we can write here y equal to x to y infinity and x is 0 to infinity. Now we draw the region of integration. So this is the line y equal to x. Now see, the integration limit of y starts from x to infinity. So like this. So y is x and y infinity in there. And x is 0 here to indefinitely. So this is the region of integration. So you can write the region of integration is as shown in the figure. Now to change the order of integration, now first we need to find integration with respect to x first. So we should take a horizontal streak like this. take a horizontal strip, PQ in R, and we can now find the limits. Now x is 0 here, to x other end is on the line y equal to x, so x equal to y, and this strip slides vertically from here to indefinitely like this. So y equal to 0 to y infinity. So therefore double integration x to infinity 0 to infinity e power minus y over y dy dx is equal to x is 0 to y is 0 to infinity e power minus y over y dx dy. So integration of this part is y is 0 to infinity e power minus y over y. Integration is x is 0 to y dy. So y is 0 to infinity e power minus y over y. This is y dy. And this to cancel, and minus of e power minus y. Y is 0 to infinity. This is e power minus infinity, minus plus e power 0. This is 0 e power minus infinity, and e power 0 is 1. So the answer is 1. Thank you.